On April 7th, 2026, Intel announced it was joining Elon Musk's Terafab project. It's a $25 billion semiconductor factory in Austin, Texas, and its goal is 1 terawatt of AI compute capacity. And Intel, a company that's been losing ground to TSMC for 5 years, watching its foundry business bleed $10 billion a year, just got the keys to the kingdom. This is either the deal that saves Intel or the deal that finishes it. Now, most of the coverage you'll see treats this as an Elon Musk story, another huge, audacious bet from the world's most provocative entrepreneur. But that's not the real story here, is it? The far more interesting question is what this all means for Intel investors, because if you understand what Intel is actually doing in this partnership and what they stand to gain, the entire investment thesis for INTC looks fundamentally different. So stick with me here. By the time we're done, you're going to understand Intel's 4 distinct roles, the 3-phase financial model that takes us to 2030, the true risk and reward here, and the exact data points you need to watch to see if this colossal gamble is paying off.
Okay, so to really get why Intel is at this table, you first have to understand the corner Elon Musk was backed into. It's a problem that keeps pretty much every CEO in tech awake at night. The entire global supply of the most advanced AI chips, it effectively runs through one company in one part of the world. And that creates bottlenecks. It creates pricing risk, and frankly, a geopolitical risk that someone like Musk, who's building humanity's future with rockets and self-driving cars, simply cannot afford to have hanging over his head. And here's the thing, Musk isn't just buying one type of chip. He is fighting a 3-front war on AI hardware. First, you've got xAI, which is just insatiably hungry for massive data center scale compute to train its models. Then you have Tesla, which needs millions upon millions of small, efficient edge chips for its cars and robots. And then you've got SpaceX, which needs completely custom radiation-hardened chips that can, survive in space. 3 completely different needs for 3 companies whose futures depend on them. They absolutely cannot have that critical hardware controlled by someone else's supply chain. So you might be thinking, well, why doesn't he just build his own factory? Here's the catch. Musk's teams are world-class at designing chips. That's a discipline of logic, of architecture. But actually making the chips, fabricating them at the 2-nanometer level, that's a whole different universe. It's a discipline of physics, of chemistry, of materials science, and that gap between designing a chip and making one, you can't cross that with a big checkbook. It's a gap measured in decades of accumulated, hard-won physical expertise.
It all comes down to one word, the word that determines profit or ruin in this industry: yield. Just think of a silicone wafer as a sheet of freshly printed $100 bills. Yield is the percentage of those bills that aren't counterfeit. If your yield is, say, 40%, you are literally burning more money than you're printing. But if you can get that yield up to 80%, you have a license to print money. That difference isn't a small tweak, it is the entire business. And getting that yield up, that is what Intel knows how to do.
So what is Intel actually doing in this deal? And this is where I think most of the market is getting it wrong. People see this as a simple contractor for hire gig. It's not. It's a deeply integrated 4-dimensional partnership that goes far beyond just building chips to spec.
Okay, role number 1, and this is the big one: process transfer and yield guarantor. Instead of Musk's team spending years trying to invent a manufacturing process from scratch, Intel can essentially parachute its own proven recipe, its 18A or 14A process, and just install it right inside Terafab. This doesn't just shorten the learning curve, it practically eliminates it. Intel isn't just a consultant here, they are on the hook to guarantee the yield. Next up, role 2, advanced packaging. See, the most powerful AI systems aren't built on one giant chip anymore. They're built from smaller, specialized chiplets that are stitched together. The real magic is in the stitching. And Intel brings 2 game-changing technologies here. First is EMEB, which is like a tiny, high-speed superhighway that connects chiplets side by side. Then there's Foveros, which is just incredible. It stacks the chiplets vertically, like building a skyscraper. This 3D stacking is absolutely essential to hit that 1 terawatt compute target efficiently. The 3rd and 4th roles are where this goes from a technical deal to a full-blown strategic alliance. Role 3, Intel becomes a co-developer. They're not just taking orders. They're sitting down with SpaceX engineers to design chips that survive in orbit. They're working with Tesla to optimize power leakage for robotics. And finally, role 4, they're the policy and supply chain intermediary. Having Intel's name on this project basically unlocks the door to CHS Act subsidies. It gets you to the front of the line for those impossible-to-get machines from suppliers like ASML. You can't put a price on that kind of influence. Okay, so this is clearly a huge win for Musk, but what's in it for Intel? As an investor, what you really care about is, how does this deal fix that $10 billion hole in their foundry business? Well, to understand the solution, we have to start with the problem. and it is a stark one. In 2025, Intel Foundry Services lost over $10 billion. $10 billion. You see, a foundry is a business of massive scale. You build these incredibly expensive factories, and if they aren't running at nearly full capacity, you are just hemorrhaging cash. To make it work, you need a giant committed customer to fill that factory, an anchor tenant. Well, they just found the biggest one on the planet.
Now, the financial payoff here doesn't happen all at once. It's not a light switch. It's a ramp. And you have to look at the money from this deal in 3 very distinct phases. The first phase, from now through 2027, is all about the build-out. This is the setup, the prototyping, laying the foundation.
During this first phase, Intel basically gets paid for its brain. We're talking high-margin service contracts, engineering fees, the payment for the expertise. That's probably $1 billion a year right there. Then phase 2 hits around 2028, 2029. This is the volume ramp. Wafers start coming off the line. This is where revenue starts to scale in a big way. Think $3 to $5 billion a year. That alone might be enough to push the whole foundry business into profitability. And then comes phase 3, 2030 and beyond. This is when the factory is up full steam. At that point, you're looking at a steady, recurring $10 billion plus annual revenue stream. That's not just a contract. That's an annuity that completely transforms Intel's financials.
But here's the thing. That $10 billion a year, that's just the direct money. There is a second-order effect here, a global demonstration effect that could be worth even more. And this is the part I think Wall Street is completely sleeping on.
This Terafab project becomes Intel's single greatest marketing tool. Think about it. If you can successfully satisfy Elon Musk, arguably the most demanding, obsessive, and difficult customer on the planet, who can't you satisfy? It sends an undeniable signal to every other hyperscaler, from Google to Amazon to Microsoft, that Intel Foundry is for real. It's a proof point you can't buy with a Super Bowl ad. This one win could be the key that unlocks a dozen others just like it.
Okay, stick with me here, because this is where we zoom all the way out. This isn't just a story about one company or one deal. This is about a tectonic shift in how the entire technology industry is being rebuilt. For the last 30 years, the entire trend in semiconductors was fabless. You design the chips, and someone else builds them. Specialization was everything. This deal slams the brakes on that trend and throws it in reverse. This is a return to vertical integration. What we're seeing is that to win in AI, the biggest players need to control the entire stack, from the software all the way down to the custom silicon it runs on. Apple figured this out years ago with their M-series chips. This is that same playbook, just scaled up to the level of planetary infrastructure. And of course, you can't tell this story without talking about geopolitics. There's a reason this is happening in Texas. Because right now, if you want the most advanced chips in the world, more than 90% of them come from one island. So you have to see this for what it is. The Terafab isn't just a commercial factory. It's a piece of strategic national infrastructure. This is a national security level deployment to build a resilient domestic AI supply chain for the most important resource of the 21st century. In the world that's coming, AI compute isn't just economic power, it is national power. And this project helps bring that power home.
Now, the story I just told you is the bull case, and it is a powerful one. But an investment thesis without a clear-eyed view of the risks is just hype. So what could go wrong here? How does this whole grand vision blow up?
Well, risk number 1 is cultural. You've got Musk's move fast and break things ethos crashing head-on into the measure 1,000 times cut once world of Intel. These are two fundamentally opposed ways of operating, and if they can't find a common language, this project will seize up. Risk number 2 is the capital black hole. If they can't get the yields up on schedule, this $25 billion factory becomes a furnace that does nothing but incinerate cash. And finally, risk number 3, the competition. You don't think TSMC and Samsung are just going to sit back and watch this happen, do you? No way. They are going to fight tooth and nail to stop Intel from gaining this kind of momentum. So, how do you track this from the outside? What are the real signals to watch for? I promised you a watch list, and here it is. First, in the second half of 2026, keep your eyes peeled for any pilot production yield data. That's your earliest hard number. Second, look for specific public details about the advanced packaging contracts. The more specific, the deeper the partnership. Third, watch for the official CHIPS Act subsidy confirmation. When that money is locked in, a huge amount of financial risk comes off the table. And finally, every single quarter, look at one number in Intel's earnings report, the foundry capacity utilization rate. That number tells the whole story. As Terafab ramps, that number has to climb. Markets reward the people who do the work before the crowd shows up. You just did the work. See you in the next one.